Hello, and welcome to track 3 of SeaGL 2021. For our final talk of the day, we have Ben. Ben Cotton is a meteorologist by training, but weather makes a great hobby. Ben works as the Fedora program ambassador at Red Hat. He writes for opensource.com as an open organization ambassador and correspondent. Ben is a member of the Open Source Initiative and a supporter of the Software Freedom Conservancy. And please welcome him today. He's going to be talking about your bug tracker and you.
All right, thanks for the introduction, Josh. Welcome to the talk. I want to cover a few housekeeping notes here to get started. I use he, him pronouns. The usual disclaimers apply. So I do have a job. This talk does not represent them or any projects I'm associated with, blah, 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 blah. The talk is under a Creative Commons Attribution Share Alike 4.0 license. If you have kind things to say, my Twitter handle is @funnelfiasco. It's on the bottom of every slide too. Kind things can be disagreements. I'm happy to engage with you on those. But if you have unkind things, you are, of course, welcome to keep those to yourself. And then we'll do questions at the end. I'll try really hard to come in at the right amount of time. Practices have been so far. All right, so what are we going to talk about here? Well, first, we'll talk about why you even have a bug tracker. Then we'll talk about how to triage the bugs in that tracker, how to close them, and then how to analyze them so you can kind of learn things about your project. So the first question, why do you have a bug tracker? Pretty obvious answer, right? To track bugs. Duh. Right, okay. So it's a little more than that, though. And I don't think it's too far of a stretch to say that bug trackers are the cornerstone of building an open source community. And just in the same way that a building is more than just the cornerstone, making your community is more than just having a bug tracker, but it's a really foundational piece. And why is that? Well, bug trackers are how you communicate with your users. It's how users tell you what is wrong or what they would like to see in your software. It's where you help them figure out how to use it. It's basically like the fundamental way of communicating from within the project to outside the project and vice versa. Similarly, use it to coordinate with contributors because you can assign a bug to yourself and work on it and then fix it and away it goes. But somebody can see, oh, Ben's assigned that bug to himself. I'll go work on this other thing. If you have a bug where you don't have any concept of assignees and everyone fixes this one bug, you have 100 people fixing the same bug at the same time. It's a really fixed bug, but all the other bugs are just sort of languishing. It also allows you to maintain a historical record for your project, and not like in a useful, I'm going to sit down and read this book, look at the pretty illustrations kind of way. More of a, wow, I'm going to Indiana Jones my way through this library. But there's a lot of very rich data that accumulates in a bug tracker over time that allows you to go back and do some of that archaeology later if you need to. And so it just sort of builds a source of information about the project, not just of the bugs, but it's an indicator of how active your project is, who the active people are, how your project works, right? So it just sort of communicates outwardly and inwardly how the project is working. And so it makes it a really important part of your project. So I think now we can agree that we should have a bug tracker. Cool. So how do you triage bugs? And so triaging is basically the act of like sorting into what order you're going to work on things. In like mass casualty instances, doctors will perform triage to be like, all right, well, this person we can't save, so we're not going to waste our resources trying to, but these people are critically injured and we can save them, and these people can sit and wait for a while. Thankfully for bugs, there's not like the ethical and like moral weight to it, but we still do sort of the same things. We figure out what categories things fit in. And so in our first pass, you ask questions like, is this a bug? Because bug trackers often have things that aren't bugs. They might be like enhancement requests, and those might be valid things to put in there. It might be things like, spam, because if it's on the internet and people can write to it, it will get spam at some point. You might have just sort of like user support questions that aren't really bugs, but something's unclear. So you want to sort that into the right category. And then you ask, is it a duplicate? Because if it is, you just kind of want to smush it down all into one, so you reduce the overhead of having to answer the same question 10 times. And yes, this was fixed in version 1.2.3. Yes, this was fixed in version 1.2.3, etc. Is it a security bug? Because you might flag those differently and either give them a quicker fix, or you might have a security expert that needs to look at it, things like that. You can ask, is it filed in the right place? And that means within your project, if you have multiple components of it, because it's a large complex project, or like, is your app written in Python, but the bug is actually in the Python interpreter itself? And so you might be like, hey, sorry, you need to actually go here to file this bug. And then some sort of questions about this that make it easier to figure out if it can even be fixed. Like, is it reproducible? And does it say what happened? So you go through and you do that first pass. And now you need to figure out which order you're going to fix things in now that you've kind of got them neatly stacked. And in open source projects, people don't necessarily follow like a strict priority. They're going to work on the thing that is both interesting and also within their skill sets, like that Venn diagram overlap. I could want to fix a Wi-Fi driver bug. I do not have the skills to fix a Wi-Fi driver bug. So I'm not going to do that. I'm going to go fix this other thing. Like there's a typo, I can fix that. But you can set sort of cultural expectations within your project of how you generally want to prioritize bugs, with the understanding that each individual person is going to sort of work on an individual basis. But you can set broad categories at least. And so you work through this list of questions, and what we're going to do is we're going to go through each one. And the sooner we get to yes, the higher the priority is. And then the more yes answers we have, the higher the priority is. And I suggest that you don't try and like individually rank each one in a particular order, because again, that's not how people are going to work on them. A couple of broad categories like low, medium, high, and OMG, those are probably sufficient. Just we're talking broad categories here. So a couple questions that are yes, like this is absolutely, we have to fix this now. Super high, urgent, whatever you want to call it, priority. Can physical harm result? And there are two ways that physical harm can result. And you're like, but Ben, this is software. And yes, but software is generally involves hardware at some point. Even serverless has servers, right? So if it's, controlling some, electrical current on a device, and you overdraw the current and it catches fire, that's a physical harm. If you have people's addresses and you have a bug that causes them to be leaked to somebody, and somebody can then find out where a user of your service lives, that can result in physical harm. And those are things you have to fix like right away. Another very high priority question is, does it cause data loss or corruption? People are generally going to be very unforgiving if you destroy the pictures from grandma's 90th birthday party, or the video of baby's first steps, their PhD dissertation. And yes, you can say, well, they should have had backups. And yes, but that doesn't mean they're going to like it. And it's a really bad thing for your software to do. So we go a little further down. This is also still bad, but maybe not quite as bad. Although the third one I'd say is still probably high. Does it permit unauthorized access? And this kind of goes back to the physical harm question of, so even if I can't get into and cause damage, like by erasing or deleting or modifying files, can I get in and see information that I'm not supposed to be privy to? And, addresses and personal contact information, like things like that, that's really bad. If I can see, somebody's notes from the fever dream they had at 3 a.m. about the book they're going to write about platypuses writing JavaScript. Not quite as bad, but it's still like, that's a huge thing. And that has real harm to people. If you think about how many times have you gotten a notification saying, oh, well, we had a data breach, here's 2 years of free credit monitoring, because servers didn't get patched on time. Like there's still like real costs to people. You can ask, does it reduce accessibility? Because if people who use screen readers all of a sudden can't use the screen reader anymore, that's a problem. Is the default configuration affected? And the reason you want to ask this is because most people, they're not the kind of people that are going to sit down and like play with all the settings as soon as they get a new piece of software or a new device. Many of us do, being here at a tech conference, but the average user, no. So if the bug ships in the default configuration, that's like 80% of your user base that's going to hit it. If it doesn't hit the default configuration, maybe there's like 15 or 20% of people that might use it. So like the impact is immediately larger if it's in the defaults. And then you think about like, is there a reasonable workaround? And reasonable here is something that the average user of your software can do. And so that's almost certainly not going to be, well, recompile it on a Tuesday morning with this special flag while you're standing on one foot and tugging on your ear. Yes, that's technically a workaround, but it's not a reasonable one. And that's why I put it in italics. And then think about, does the bug affect all platforms? If the bug only shows up on Windows 3.1 running on a Casio calculator watch, probably not that important. But if it shows up, if you're it's a mobile app and it shows up on like ARM devices, yeah, that's a problem. If it's a desktop app and it's showing up on Windows on x86, 64, that's a problem because that's like 95% of the world desktop market right there. So you want to be, again, think about the breadth of the impact. And then there's like, does it embarrass you? And this is kind of low priority. Anything that doesn't, if it doesn't embarrass you and it hasn't been yes to any of those, it's a low priority bug. And this is embarrassing, not like in the, oops, I can't believe I, made a bug. How terrible of a programmer am I? But it's in the things that like are going to get you raked over the coals in a review in like Tech Press or something. Like, does your splash screen have your project name misspelled? Functionally, that doesn't hurt anything, but it's just kind of embarrassing and gives people a really bad, first impression of your project. So that's the thing you might want to think about. All right, so we've got all the bugs sorted. We know which order we're going to work on them in. Now it's time to close them. And probably do some fixing in them, but this isn't a talk about fixing bugs. It's a talk about using the bug tracker. So we're going to assume that fixing happens at some point, probably. And I'm of the opinion that you should totally close bugs. And we'll talk about this more in a little bit. This is not a universal opinion. If you disagree with this, please give your own talk. This is my talk. And so the prevailing opinion is you should close bugs. Okay, but there is some like reasonable debate about this. The advantages of closing bugs, and it's not just when they're fixed, but when you know they won't be, or when it's reasonable to assume they won't be, is it sends a clear signal of intent. After 5 years, if you haven't fixed this bug, you're probably not going to. And I think to some degree, it's better just to admit that and not lie about it. But it also makes the bug tracker easier to search. And I don't mean like through the API where you use like 10 different keywords to get the exact set of bugs you want. But it's sort of like the visual search when you first load the bug tracker, because a lot of trackers are, they default to only showing the open bugs, which makes sense because if they're closed, you no longer care about them for most uses. And so if you have like 100 bugs open, but there's only like 3 you actually care about, it's a lot harder to find those 3 than if you just close those and you open the bug tracker and, oh, look, here are 3 bugs. On the other hand, it makes people angry when you close their bugs and you haven't fixed it. And that's understandable. I get it. And that's why some people say, we're just not going to touch that. There's also I was going to work on that someday. And, sometimes people do come along and they see a 4 or 5 year old bug and they're like, I can fix that. And they do. It's pretty rare, I expect. And if you're using different closure types on the bugs, you should be able to go back through and see the ones that were closed, unfixed, and find them anyway. And then the other argument is that it represents a catalog of known issues. And I put the asterisk there because like it's known that they were filed. It's not necessarily known that they're actual issues unless somebody's gone through and triaged and, confirmed them. But, some people do like to be able to tell, I installed this new software. I know it has bugs. What bugs does it have? And that is a way to do it. All right, but let's say we're going to decide to close a bug. Well, when do we do that? Obviously, when it's fixed. And there's actually a little bit of nuance here because do you close it immediately when the fix hits the repo, or when like the update is released, or a little bit after the update is released, so people who haven't upgraded right away can still go back and see it? We could get into that, but we don't have time. On the other hand, if it's a duplicate, or if it's invalid, or if it's spam, you can close that right away because it's a pretty easy decision. There you go. If it's missing information, or if you can't reproduce it, after a while, it's probably a good time to close a bug. If it's reported against a version that has reached end of life, you can close the bugs because that's what being end of life means. It means you're not going to fix that version anymore. And then sometimes there are just other reasons where that you can't or you won't fix it. Maybe you're actually depending on the bug for a lot of other behavior. And if you fix that, you have to basically re-architect the whole application. And while that might be the right thing to do, it's the thing that's not going to happen. So let's just be honest about it. Or maybe there's some other reasons we're like, what, we're just not going to fix this. And I'm sorry, but it's time to move on. And again, like once you've sort of made that determination, you can just close the bug. All right, so how to do it. This is the hard part because this is what gets you yelled at when you close a bug. Every 6 months I close a few thousand Fedora Linux bugs that didn't get fixed. And invariably there are people on the mailing lists or on social media or in the bug itself being like, oh, you never fix my bugs. Why are you closing this? I'm never using your project again. And I see them again in 6 months. And I'm like, but okay. But the point is, you want to set and communicate a policy ahead of time. Like, principle of least surprise here. Don't surprise the users by closing the bugs. And yes, they may not have read the policy, but at least it's out there in a way that people can see it and it's agreed upon. And this allows you to, sort of act consistently, which is good. So when you're closing the bug, explain why. Is it because the version is end of life? Is it because you depend on that buggy behavior to make the rest of everything else work? Is it that you can't reproduce it and, sorry? And give instructions on how to reopen. So that means like, if you're closing it because it's end of life, say, hey, you reopen it if it's against this current version, if it's still there. Or say we're closing this because you didn't provide all the information we need. We waited a little while. If you have that information, reopen it. And honestly, the hardest part is ignoring the complaints. And that's not like don't care about your users, but you don't necessarily need to engage with every single person who complains because they're frustrated because their bug didn't get fixed. Because you should have empathy for them. It's hard. So the process for closing your bugs is going to vary by type. So obviously, like I was talking about earlier, some you can close right away, some you want to wait for. You definitely don't want to be too aggressive with the missing info and can't reproduce closures because you want to give people time to give you the information that you need and come back to you. So you might wait a couple of weeks, just in the same way that you don't want them to expect an immediate reply from you. You shouldn't expect an immediate reply from them. And you need to figure out what you're going to do with won't fix bugs. Do you close them or do you just kind of leave them indefinitely? I'm going to talk a little bit faster now because we're running out of time, but bug analysis. You use that because you want to learn things. You can learn about your user community, and it's way easier than doing a survey because surveys have a lot of validity issues when you just try and like get it out to random people because, there's selection bias in who takes it. You don't know who's in the population. You don't necessarily have a way to communicate with all of your users. So this gives you some, defensible answers about things like usage by platform. If we assume that bugs are basically evenly distributed and you see that all of your bugs are occurring on OS 10 and none on Windows, okay, people are probably using Macs for your application the most. If you have different components, again, you can kind of see which ones have the most bugs. All right, that's probably relatively proportional to the usage. Are people filing bugs against the new version right away, or is it like 6 months or 10 months later? So you can kind of see how quickly people are adopting the new version. And you can learn trends in your project, like, are the bugs increasing over time? Or is it increasing as fast as our community is? Are we fixing them better, faster or slower? Are the bugs getting more severe or less severe? Maybe we need to adjust QA procedures. There are also things you can't learn. You can't learn how quickly you respond to bugs unless you manually set that, because you really don't have a good way at scale to tell if the first comment is somebody following up on the thing they just posted, or somebody else saying, yep, me too, or somebody from your project actually responding. It's a really useful thing to know, but you can't really get it unless you do a lot of manual work. You just want to avoid doing anything that involves people. You don't want to shame the people who are the worst bug fixers, and you don't want to praise people who are the best, because just because they're the assignee on the bug doesn't mean they're actually the one who fixed it. And there might have been multiple people who contributed to that. Similarly, you can't tell affiliations, and because people might not use their corporate or project email address in the bug tracker. And so you can't really say, oh, well, X percentage of people are from Red Hat because they use their Red Hat email in Bugzilla, because a lot of people don't. And the cool thing is you can challenge your own assumptions. So I used to think that every bug in Fedora Linux was marked as urgent because people were always like, this is urgent to me, that's why I bothered filing it in the first place. And then I looked at the data and, oh, yeah, actually most people don't set severity at all. And the distribution is actually probably pretty reasonable. Only a small percentage over the last 10-ish releases are marked urgent. So when you're doing an ER analysis, you want to look for trends that will cause a change in behavior. You can look for things that are just sort of interesting, but really want to focus on what can we do to make this better or worse. You generally want to ignore the duplicates, and basically always want to ignore spam, because it's going to skew your data. Unless you're trying to figure out, this question that you're asking is, how many spam bugs are we getting? In which case, yes, don't ignore spam. Think about percentages versus raw numbers. Which tells you sort of the story that you're actually trying to get at. If there's 10 bugs and one of them is urgent versus 100 bugs and one of them is urgent, those are different things. And raw numbers will give you one story and percentages will give you another. And I just talked about sort of, being careful how you skew your data by what you include or exclude. There's probably be a whole nother talk on this. So to wrap up, because I went long, I did do a 25-minute talk at Nest with Fedora about, it's called Exploring Our Bugs. It's basically just a bunch of graphs on Fedora Linux bugs if you're interested in that sort of thing. But now I will go ahead and take questions. I will briefly mention that I am working on a book, Program Management for Open Source Projects, due out hopefully in early next year from Pragmatic Bookshelf, that has a whole chapter just on this talk and many other things. So if we don't get to it today, you know what to do.
Awesome. We have one question from chat from Rachel. Question: are there systemic ways in the bug tracker to help bug fixers who need a lot of help?
Can we get a little bit of clarifying on the question? I'm not quite sure what the question is asking.
Yeah, if you could clarify what your question was there, that'd be great. We have other folks typing as well. I will, while people are typing, this track was sponsored by Google. They're a gold sponsor this year. And Ben, what do you think the best FOSS tool is for bug tracking?
All bug trackers are terrible in different ways. I could probably go on about this for a long time. I think tools like Bugzilla are really good for large, complicated projects. The UI is unpleasant, let's say. I think things like GitHub or GitLab issues are often too simple without doing a lot of custom fields, but they are very user-friendly. So it really sort of depends on what the needs of your project are.
Cool, thank you. And we'll give Rachel a sec. Okay. Rachel says, you mentioned that you need to watch out for praising good or bad bug fixers. Other than offering personal support, is there anything in the bug tracker tools themselves to help bug fixers get better at fixing bugs?
Yeah, so I'd say like broadly, sort of look at the aggregate time to resolution and just one, get a sense of, how well you're doing, sort of across the project. I think a lot of it, if there's somebody who's just kind of bad at it, it's going to be a lot of coaching. Be like, let's look at some of these bugs and see why. Were they mistriaged, or did you get unlucky and you get the really complicated bugs, things like that.
So you're saying you should use the metrics in order to identify problems.
Yeah, and again, like you might, if it's a complicated project, you can break it down by component. And so you can get a more granular view. And you can actually, do it by individual. You just got to be really careful that the data might actually be meaningless. And you certainly wouldn't want to make it like public, but you could, if somebody's like, hey, how am I doing? You can, then just look at their bugs and kind of get a sense for it.
Yeah. Okay. Well, thank you so much, Ben, for speaking. Everybody, we have a closing keynote in, I believe it's in track 1, and we will also have closing ceremonies, games, stuff happening. Stuff is happening. Please go to the keynote, and this is our last talk in track 3, so I am signing off. Thank you very much, Ben, and thank you to all of you for listening.